All right, so getting into chapter 13, lesson 6, measures of center and variability. So we're going to be looking at different graphs and different charts and points of information and just comparing the two that we go through. For example, we have Julia here. Julia is doing a report on different sports teams, specifically with baseball. We have basketball that she's comparing. And what we're comparing is how high or how tall the players are in their heights. So when we talk about this information, it says compare the medians and the interquartile ranges of the two teams to figure out what the differences are between one team and another. It starts out, it says, we're going to use the median here. It says the median of the blank player's heights in inches greater than the median of the blank player's heights. So how do I know which is which? Well, when I look at it, and I know I'm talking about the medians, and then it says it's greater than the other median. So if I look at the medians and I do a subtraction, I can see which one is truly greater than the other. So we're talking about the median, so it's just the first column when we're talking about between the baseball and the basketball. And the median of the baseball is 70 inches, where the median of the basketball is 78 inches. So when I look at it then, I know that when I look at the difference between the two, then I have a difference of 8 inches. So the median of the basketball player's height is, and then it says greater than, so that's where the 8 comes into play. It's 8 inches greater than the median of so the second team then is the baseball players. When I compare the interquartile range then, because that's what it says we're going to be using here, then I have to look at the second column. Second column is interquartile. We know, once again, she made a box plot to compare this information. If I use the interquartile and I read it, I have to figure out what it's telling me, what the difference is there. The interquartile range of the baseball team is blank. The interquartile range of the basketball team. Well, when I look at it, here's the baseball and here's the basketball. So when I look at the difference, then I know it's greater than, because the interquartile range of baseball is larger than the interquartile range of the basketball team. It is greater than the interquartile range of the basketball team. So the heights of the baseball players vary more than. So the baseball players over here have a bigger difference between all of their heights compared to the clustering that is closer for the basketball players. So those players, they vary more than the heights of the basketball team. So the players on the basketball team are typically taller because we know our median is 78. Then the players on the baseball team, and the heights of the team vary more than those of the other team. So when we talk about the differences then, the interquartile range, then I know the baseball team's heights differ more than the basketball team. So what we're told then is what we're trying to get to the point of is by looking at this data and this information is that in this team, we know that the average height, the median height, the center point of the basketball team is taller, which would make sense. You would expect basketball players to be taller than others. But when we look at the height differences and the variance that we have, then we know that there's a bigger difference between the baseball players' height and the basketball players. More of the basketball players are closer together in height. For the baseball players, they could be anywhere from 5'5" to 6'5". So when I look at number one, then it says Julia randomly picked one player from the basketball team and one player from the baseball team. Given the data in the table, which we just did, can you say that the basketball player will definitely be taller than the baseball player? Explain your reasoning. Well, when we think about that logically, that answer is just no. I can't definitely say the basketball players are taller than baseball players. We have some very tall people who used to play baseball or still do professionally. Randy Johnson was a very tall man when it came to being a tall pitcher. So when we look at the information, my explanation then has to come from the information that I'm given. The median height of the basketball players is greater than that of the baseball players. However, but that does not mean that they are all taller than each of the team players. There could have been some baseball players that were taller than some of the basketball players. I can't say the basketball players are absolutely taller than. You could have a 6'7" baseball player and a 6'2" basketball player. Both are rather tall compared to me, but I can't say for sure one is going to be taller than the other. So if you don't have that written down, then please pause the video now and then continue back with me. So then I look at t-shirts. So we have a t-shirt fundraising that's going on. I have Kamira and I have Joey. So Kamira and Joey sold t-shirts during lunch to raise money for charity. The table shows the number of t-shirts each student sold. So we have Kamira and all of hers that she sold, and then Joey and all of his that he sold. Find the mean and range of each data set and use this measure to compare the data. So we're going to start with finding the mean with this page here. And this is going to be at the top of your paper, but I just have it on one slide. So when I find the mean, then once again I have to add them all together. I once again like to put them in order from least to greatest. It's not required on me to put them in order from least to greatest, but I do think it helps when we get a little later on into problems. So when I have them all listed for Kamira, then I know that we're talking about selling for 10 days. So I'm going to take my total, because the mean means average, and divide by how many days we're talking about. We're talking about 10. So 30 divided by 10 gives me an average of, or a mean of 3 shirts. Joey's days, there are some days he didn't sell any at all. 2 days he didn't sell any at all, but one day he really kicked it in and sold 13 t-shirts. But when I add them all together, I'm going to get a different number. Now, I put a star here because your book reminds you of something that I told you in the last set of videos. When we're doing mean, we have to include the zeros in our total data set because it would throw off our average if we don't. So I'd have to include those 0 days. I can't just say, well, he only sold for 8 days. No, he sold for 10. He just didn't sell any on those 2 days. So then I still get a total of 30 out of 10. So I see that my mean is also 3. So if I just go by my averages, they sold the exact same amount. But that's not the case. So then when we go down to the second part, step 2 is to find the range of each of the data sets. So I'm going to put that back up here. This is the data that we just had figured out on the previous slide for this video. But when I talk about my ranges, then I look at Kamira's range. And so I have to go to Kamira and I have to find the largest and the smallest numbers. So I'm going to take my 5 and subtract 1. So I have a range of 4. With Joey, he sold 13 on that really big day, but there were days that he didn't sell any at all. So his range is from 13 minus 0, which is just a range of 13 possibilities. So when I looked at the mean and the range, the mean of Joey's sales is the same as the mean of Kamira's sales. But the range of Joey's sales is greater than the range of Kamira's sales. So what that tells me is that there were some days that Joey was really active and other days that he wasn't, where Kamira, she stayed pretty consistent throughout the entire time. So the typical number of shirts that Joey sold each day was the same as the typical number of shirts that Kamira sold. However, since the range of Joey's data was greater than Kamira's, the number of shirts that Joey sold varied more from day to day than the number of shirts that Kamira sold. This isn't difficult things to understand. It's just being able to explain the data that we're looking at. We're going to be doing this for the next couple of lessons, but then we don't really deal with it a lot. You're going to see it on NWEA. You're going to see it on the I-STEP, but you get more into using data and explaining data in 7th and 8th grade. So this is really an introduction and your foundation for your next 2 years of junior high math. So I just really want you to be able to understand this and just be able to tell me in words what kind of information you're gathering from the data that we're seeing. So let's go to Zoe. Zoe collected data on the number of points that her favorite basketball player scored in several games. Use the information in the table to compare the data. So when I look at it, I see player 1, his mean was 24, his interquartile range is 8, and player 2, his mean was 33, and interquartile range is 16. So going through and filling in the information, what can we gather? What can we understand from that data chart? The mean of players 1's points is what compared to the mean of players 2 points. So we're looking at that first column. Well, players 1 is less than the mean of players 2. I can tell that from the information. The interquartile range of players 1's points is blank the interquartile range of players 2 points. Well, it is also less than from the second one. So I have a mean that's less than player 2, and I have an interquartile range that's less than player 2. So player 2 typically scores blank points than player 1, more points, right? Because that's our mean. But player 2's scores typically vary more than player 1. So what that tells me is when it comes to being a reliable scorer, they score more, but how they score is very different. So maybe they score consistently 4 points per game, and they're scoring, maybe 1 here and maybe 6 here and maybe 7 there, but 0 there, and it becomes a very wide range of who is more dependable. So when I talk about box plots, the closer it is on the information, the more dependable it is. The wider that information, the less dependable it's going to be. The second set of questions then goes to Mark, and they use this puppy weight in pounds. And he uses 2 different shelters. He has a shelter A and a shelter B, and he looks at the weights of the puppies. It says that Mark collected data on the weights of puppies at 2 animal shelters. Find the median and the range of each data set, and use these measures to compare the data that you're collecting. So in order to find the median, then that means I have to put them in order from least to greatest. So when I start with shelter A, I put them in order, and then shelter B, I put them in order. And then I find the median by going from the ends to the center, and I see that I have 7 as my median for shelter A. And then for shelter B, I do the same thing. And I see that my median is 11 for shelter B. But it also says to find the ranges. And once again, my range, not my interquartile range, but just my regular range, is subtracting my largest number and my smallest number. So when I find my ranges then, I have 15 minus 5, which gives me a range of 10. And I have 15 minus 4, which gives me a range of 11. So when I look at the information then, I'm going to state the information first. So in shelter A, my median was 7 pounds. My range was 10 pounds. And for shelter B, my median was 11 pounds, where my range was also 11 pounds. So what does that tell me? Well, what that tells me is that the ranges are similar. They're not too far apart. 1 pound when it comes to puppies isn't that big of a difference. But the typical weight of B is greater than the weight of A. When my median is a harder or a higher number, then I know that it is going to be a larger number in a regular basis. So I know that my B weight is greater than A on a regular basis. Make sure you have that information written down. Pause the video and then come back. As we move on to 3, 4, and 5 then, we're going to take this information, we're going to look at the information as we finish up here and talk about what it's mean. Now, some of my answers could be multiple answers, which we'll see here in just a moment. It says, Quan analyzed data about the number of hours musicians in her band practice each week. The table shows her results. We're supposed to use that for these 4. So I have Sally, I have Matthew, I have Tim, and I have Jennifer. And we're talking about the mean, the average amount of time that they practice, and the range in which the amount of time that they practice. So in our first question, it says, which 2 students typically practice the same amount each week and with about the same variation in practice times? So we're looking for a mean that's about the same and a range that's about the same. It doesn't say it has to be exactly the same. When I look at a comparison then, I can see that Sally and Jennifer both practice about the same amount of time, 5 hours and 5 hours, and their variation is only a 1 hour difference. So they're close to the same time. So 3 would be Sally and Jennifer. When I look at 4 then, it says, which 2 students typically practice the same number of hours? So that's my mean again. but had very different variations in their practice times. So when I first look at it, then I'm looking for the same hours. I have 5 and 5. And when I look at Sally and Tim, there's a huge difference in their variations. Sometimes Sally was in a variation of 2, but Tim's was in a variation of 12, which means some days he could have practiced none at all, and some days he could have practiced several hours. But if I look at it, I also have 2 others that I can compare because there's another set of 5. When I look at Jennifer, Jennifer also has the same 5 for the average, but has a variation of only 3 compared to a variation of 12. So there's actually 2 answers there that you can have. You could have Sally and Tim, or you could have Jennifer and Tim. Either one would be considered correct because they can both be supported by the information in the chart. Number 5 then says, which 2 students have the same variation of practice time, but typically practice a different number of hours per week? So a wide variation, that's my range, but the same, not the, or a difference in the amount of time. So my variation is the same on Matthew and Tim. They both had a wide variation in the range of 12 hours. At their time was more different then because the time for Matthew was his average was 9 hours, where Tim was only 5. So we would say Matthew and Tim had the same variation, but their time frame was different per their weekly hours. So the lesson, once again, is just about looking at the data and comparing 2 sets of information, at least 2 sets, and figuring out, which is more comparable, which one is going to be more correct than the others. So you have even one less problem for tonight's homework. You have 2, 3, and 4, 1 and 2 on the back. So you have 5 questions that are going to be about this type of information we just went through. And then you have 3, 4, and 5, just 3 review questions that you have to do on the back. So if you have any questions while doing it, then come to me and ask.